off our video feeds when we do the main presentation. Just for introductions, we'll turn it on. So you're welcome to turn off the video. It just saves on bandwidth as well. We're going to be recording the session, so it's already started. Bron, thanks for that. A copy of the slide deck, we'll make it available afterwards if you would like it in a PDF format on request. So just drop us a line in the chat box or by email afterwards, and we'll send you the slide deck. And of course, the recording will also be available. Questions in the chat box if you want. I've got a team of guys who are monitoring the chat box, and will try to answer the questions in a live sense if they can. Otherwise, we'll tackle those in the Q&A afterwards. And if we don't have the answers, we'll get back to you at a later stage. So use the chat box to ask some questions. All right, so what's the topic today? We're chatting about GeoCue UAV LiDAR solution, introduction to South Africa. So recently, we've signed up an agreement with the guys from GeoCue, and we've brought on their amazing hardware and software solutions into our portfolio, and today we're here to tell you all about it. So joining me on the presentation, we've got Lewis Graham from GeoCue. You can see him; his video is live at the moment. He's the cool guy with the fancy headset. And he's going to be running through a number of slides later on the technical elements of the gear. Lewis is the co-founder and chief technical officer for GeoCue. So he's the guy who knows everything. So if he doesn't know it, no one knows it. All right, and myself. So my name's Sean. I'm the new business and technology manager for OPTRON, and be facilitating hosting the session over the next hour. So over the next hour, we'll take you through a number of really interesting things, and then we'll obviously wrap up and close up with some Q&A at the end, and hopefully you guys get a lot of insight out of what we want to share with you today. All right, I'm just going to quickly change the slide deck, and then we'll get cracking. All right. Everyone can see the slide deck. Maybe Brian, just give me an indication that it's all good to go.
All good, Sean. All
right, thanks. Thanks very much. All right, so introduction of GeoCue LiDAR to the African market. So today we as OPTRON represent SenseFly and DJI in the drone space.
Sorry, Sean.
SenseFly
it's not in presenter view, it's in your...
Yeah, good point. You guys are, there we go. Ha! See, I'm a novice at this whole thing. All right, thanks again. All right, so today we're representatives of SenseFly, the EB series of drones with sensors, DJI Enterprise with their drone platforms, Mavics, Phantoms, M300s, sensors, P1s, H20 cameras, H20Ts. And we've been doing pretty well with these solutions, but there's a certain gap in the market that's opened up. Guys want data faster, more accurate, and they also want to use drones to do it. And the obvious gap to fill is that of LiDAR. So we evaluated a number of integrators and vendors across the world, and we came up with GeoCue at the top end. In my world, I believe they put a fantastic piece of kit together, or they've got 2 or 3 offerings, and some really good software to cater for the point cloud data process and deliver a fantastic solution. So we're going to share this with you guys today, and I'm going to hand over to Lewis, who's going to take you through some of the technical elements of the offering and chat a bit about GeoCue, and then I'll jump back on a bit later and talk a bit about the products we're going to sell in this region, and then we'll wrap up. So Lewis, over to you if you want to share your slide deck, and then you can carry on.
All right. Are you seeing my screen okay?
Yeah, we got it. Perfect.
And audio is okay?
Perfect.
All right. Well, thanks very much for putting on this webinar, inviting me to present as well. We're really excited to have OPTRON as our reseller and technical support center in Africa. It's always a lot better to have someone local than to have our own presence. So we're extremely pleased to be working with a company with as high quality as OPTRON. So about GeoCue, Jim Medlock, who was the founder and CEO of Intergraph Corporation, a large CAD/CAM founder in the United States, and today owned by Hexagon, and myself founded GeoCue in 2003. I had spent, I would lie and say I was a kid in 2003, but you had to see a video of me in the beginning, so you know how old I am. But prior to this company, I worked at Intergraph. I ran their commercial photogrammetry business. We had a joint venture with Carl Zeiss, where we built photogrammetry hardware and software for manned aircraft and drones and so forth. So a long time in this industry. We're located in Huntsville, Alabama in the United States. We're located here because that's where Intergraph was founded, and a lot of my team came out of the Intergraph. We have a small office in Toronto, and we just stood up an office in Australia. We've got about 4 persons working there. And our focus in the company has been, in the beginning, it's been airborne and mobile laser scanning solutions. We focused primarily on software for quite a few years. And we've always done enterprise management, data management solutions. So we do a lot of things in Amazon Web Services for large sensor systems and so forth. So that's been the bulk of our company. In 2012, we started looking at the drone industry because a lot of our solutions fit that space quite nicely. And that business has grown to be really now, when I looked at it just a few weeks ago, it's become about 50% of our business without sacrificing the other business. So I think, as all of you know, it's a strong indicator that drone is it's a real growth area. You know, it's quite obvious why it is. I can go put sensors in places where it was difficult to put them before. We did all sorts of different things in the drone mapping industry that ranged from photogrammetry systems to direct geopositioning and so forth, sort of, you know, feeling out the industry and what's going to be the technology that people adopt and you know, is profitable for their companies. So in 2019, we focused on laser scanning systems, but we realized that you really need an RGB colorized point cloud to be effective in that business. It's not enough just to have an elevation model. So we came up with the idea of doing integrated cameras with our LIDAR system. Now, a lot of people provide cameras with their LIDARs, but we do it in a little bit different way, and I'll explain what that means as we go through this technology. We do a lot of flying. We have a services group. We don't compete with our customers, but we do have some I guess old-time customers, I would say, a few mining companies and so forth that we do flights for. We've also got a few open pit mines in our area, and those companies cooperate with us a lot when we're testing new sensors and looking at their effectiveness. So we have a lot of experience on the ground actually flying these systems. And it's really interesting that OPTRON sells the EV. We have an EV in our portfolio. We were a reseller of those at one time as well. The uptake on the new TrueView sensors has been pretty rapid. We're really pleased with the kind of customers that we have adopting the technology. A lot of these names won't mean anything to you since they tend to be North American centric, but we do have Anglo-American Kumba Iron Ore in South Africa. A number of companies such as AECOM are engineering firms with global presence. We've had a pretty big uptake by departments of transportation in the United States, and they're pretty exacting in the requirements on sensor technology. So we're really getting a good footprint. I think the only reason that this kind of list is important to you is to know that you're in good company. You know, we're selling to these top tier companies that are quite demanding, and so they really keep us on our toes all the time. So I think everyone is, or I would assume most people are familiar with LIDAR. It gives you direct 3D imaging of the ground using an active sensor, which is a laser scanner. So it's a big advantage over photogrammetry. is only a single ray needs to hit the ground to get a ground point, whereas in photogrammetry, particularly multi-ray photogrammetry, I might need 5 images at separate locations that see the same point on the ground. And this is why you don't see vegetation penetration with photogrammetry alone. But adding color really adds quite a bit to the contextual ability to recognize objects in a scene. So here's an example, same scene that we saw just a moment ago, but now we've colorized it with the integral RGB cameras. And of course, we can look at an interpretation. So here I've got a drainage ditch with riprap in it, and you can really see the difference. Here I've got a color by elevation. Yeah, it's interesting. I can look at a profile view and figure out what it is, but this is such a much richer view. And not only does it look nice, but you know, the question is always, you know, does it make me more money? And of course it does, because it makes classification and extraction of features go significantly faster when you have this added RGB. Right now we've got 3 levels of sensor. I guess I would say 4 levels of sensor in our product family. So we started out with our TrueView 410 at the bottom of this list using a Quanergy M8 laser scanner. So we did a lot of research, probably 4 months of research, evaluating different scanners. We bought quite a few, tested them and so forth. And the Quanergy was a great, what I call general purpose topographic scanner. We've used the Planix positioning technology since the beginning. That's a Trimble subsidiary based in Toronto. We actually, I've worked with them since that company was founded back in the 90s. In previous lifetimes. So we have a very long relationship with Trimble Planix, and you know, frankly, they've got the best positioning equipment on the market. So we didn't want to have to worry about, did we have accurate positioning? Right from the beginning, we built mapping cameras directly into the system. Now, I'll talk a little bit more about that in just a minute. Last year, I think it was in June of 2020, we introduced a Regal class system. This was mainly aimed at engineering firms that needed to do hard pavement returns for things like highway cross sections and so forth, where very high precision and accuracy is required. Even to this day, Regal is still the only mainstream LiDAR company that is building LiDAR specifically for drones. Optech has recently introduced a sensor to the market. We've started to evaluate it, but right now the standard for survey grade DOT type accuracy is the Regal class. And we offer that with 2 different positioning systems, and I'll go into that in a minute as well. And then just recently we had a request for you know, customers that really needed a higher level of vegetation penetration and especially wire collection in a lower cost system. So we introduced the TrueView 515 just recently. That uses a 32 beam scanner. And we jokingly called it Vegemite because of its ability to penetrate vegetation and bring wires into the scene. On our systems, our goal was to really range from general purpose topographic mapping, which we do with the TrueView 410, to high level survey grade, which is accomplished with the Regal systems. And we wanted a standardized output for all of our systems, 3D colorized LiDAR point clouds, what I call fusion by design. So the cameras aren't glommed onto a LiDAR sort of as an afterthought, and they're not things like a Sony DLSR camera that's been bracketed onto a laser, but they were integrated into the system from the beginning with the idea of having rapid software post-processing. The other thing that we output is geocoded images with full what's called exterior orientation. So this is also called direct geopositioning. So you can take these images directly into photogrammetry software or use them for inspection. We wanted to keep the weight of the systems in a range that you could use them on drones like the M600 from DJI or the M300. And the big focus for us, and it was pretty easy because we started out as a software company, was to have integrated software that made the processing go fast and made it go easy. So there's a lot of LiDAR systems out on the market today, and you're probably inundated with you know, people who are making different drone sensors. But we've got the complete package. The software tends to be as important as the hardware, and it has to work fast, it has to be accurate, and it has to be intuitive. And I think we've accomplished that with our workflow software. And finally, we wanted to be independent of the drone because we have customers that want to fly on a variety of different drones. So we didn't want to be hardwired into a drone that said, oh, you have to use this particular model of system with our platform. As long as it'll lift the system and it has a clear field of view, you can carry our LiDAR system on that drone. So let's look at how this system is put together and the general components of it. So we've got the laser scanner, as I said, a couple of different models depending on your requirements. Integrated camera. So we have a lot of experience with cameras, of course, through the years, and we searched and searched for cameras. We could not find one. We finally had to have a custom mapping camera designed for us by a firm called Sept. So these are what we call GeoCue mapping cameras that are built for us by a Japanese contract cameraman, designer and manufacturer. They're photogrammetric, and what makes these cameras photogrammetric is that they have fixed focus, so they'll hold calibration from flight to flight. I don't have any focus mechanism on them. They're focused at infinity, as a photogrammetry camera should be. They have mechanical shutters, so you don't have image blur from this rolling shutter problem. And very importantly, they have an electronic signal that is sent to our main compute unit that says the camera just fired. I'm at the center point of the shutter. And that allows us to synchronize the camera to within a few milliseconds of the position that we get from the Planet's position orientation system. It's got a really simple dovetail mount. It'll mount directly to, for example, the Ronin mount on an M600 drone. We have mounts available for quite a few different drone platforms. So adding and removing this from your drone is fairly straightforward. So again, you know, the same basic model for all three laser scanners. Here we have the mid-range TrueView 515 using the 32 beam Hesai scanner. And then finally the Regal system, which is what we call the 635 and 640 systems that use the new Regal Minibux 3 UAV. So that gives you, that new scanner from Regal gives up to 100,000 points and 120 degree points per second and 120 degree field of view. So really, they've really upped the density that's available with these single beam scanners. And again, it uses either the APX15 or the 20, and I'll talk a little bit more about the difference between those. So here's an example of a laser scanner. This is a 515 that's being flown on an M300 drone. I won't go through this in detail because these slides will be provided to you. Everybody is always asking us, you know, what's the fundamental difference between the laser scanner? And so here we've listed, you know, a lot of those details in terms of pulse repetition rate and so forth. You know, I think these specs on these laser scanners are very important, particularly the noise and the range. But you're really not going to, you know, if you go read about, for example, a Pandar XT32, what you read on Hesai specs are not what you'll realize when it's integrated into a LiDAR system. So, you know, the best policy there, I think, is to work with someone you trust, like the OPTRON guys, to see, you know, what is the recommended flying height for this kind of scanner? What kind of density can I expect on the ground? Those kinds of things. And the reason I say that is that this has always been the case. It happened with airborne scanners, and now it's happening with drone LiDAR scanners and automotive LiDAR scanners, where it's a race to who can have the most points, or, you know, other specifications like that, when in fact it's all of those specifications combined together that make the difference between, am I going to be able to see wires, am I going to be able to penetrate vegetation. Some details about the camera, I've already spoken to those. Something really important that we do that is different from anyone else in the industry right now is that our cameras are very carefully mounted to the LiDAR system, which in turn is rigidly mounted to the positioning and orientation system. The entire unit is calibrated in a pretty complex calibration process that we do here at the factory, but it allows us to colorize the LiDAR points on the fly. So we don't have this intermediate step of having to go make an orthophoto and then colorize the LiDAR points from that orthophoto. That's a very time-consuming process. Our workflow just does direct colorization, gives you a better image, but it also makes the post-processing much faster. And then finally, we put the control unit of the LiDAR system on top of the drone. So we've got a little readout that tells you the status as it's booting up and so forth. When you want to fly the system, most of our customers fly it in automatic mode. So when the LiDAR system detects that it's a certain distance from the launch point, it turns the cameras and LiDAR on. When it returns, it turns them off, copies all of the data off to a USB memory stick, and then you just transfer that data to a workstation. So flying the system is quite simple. You really don't have to think much about it. And transferring the data is simply moving a memory stick. So that goes quickly. On the position orientation system, we have two levels for this. The APX-15 is a board stack that is internal to our electronics housing in the laser scanner. And then in the 640, we add, in addition to the APX board stack, an external IMU. Of course, it's trembloplanic, so it's reliable. It's it's a survey grade system with many deployments on many different types of systems. So this is definitely very field proven technology. The difference between the APX and 15 and the APX-20, of course, is the accuracy that is achievable in orientation. They both use the same GNSS. That's what gives you XYZ. And so you see the specs here are the same for both the APX-15 and the APX-20 on position. The difference is in the orientation, roll pitch, heading. Roll pitch and heading matter in a laser scanner, high altitude all the time. In a drone LiDAR system, they come into play when you're looking at off-nadir shots. We're flying at relatively low altitude, so the nadir is not the problem. But when you're looking off at 20, 25 degrees from nadir, then the difference in accuracy of orientation comes into play, particularly heading. So we talk a little bit about heading. Heading is the direction that the platform itself is pointed, not the direction it's traveling over ground. So I can get the direction it's traveling over ground from the GNSS system just by looking at differences in position. But I can't figure out the heading from the GNSS. I have to get that from my orientation system, so from the IMU section. And the heading is very important for looking at vertical objects, for example, sides of buildings, poles, towers, and that sort of thing. Accuracy in heading makes a difference in the ultimate accuracy of the point cloud. And that's where the APX-20 has an advantage over the 15. The 15's got great heading, small error, but the 20 improves on that. And we did an experiment to say, well, what is the difference between these two? And we have this plotted in this lower plot where the error of the APX-20 is plotted in orange, the error of the 15 is plotted in blue, and it really pretty much agrees with the spec. It says the 15 is about 3 times more accurate than the 20 is about 15 times or 3 times more accurate than the 15, and we see that reflected in these in this data. Another message here, though, is the overall error is quite low, even to begin with. So we magnified it so that you could see the difference between these two. Software is critically important, and we've really built a software environment that envelops our sensors. And it ranges from, we have some web-based technology that runs in Amazon Web Services that provides a number of services. One of them, some of these seem really simple, but they make a big difference in reliability and processing. For example, the calibration files for the laser scanner and both cameras is kept on our website in Reckon, and when you do post-processing of data, it's downloaded to your machine. So what this means is that if you need a recalibration, no matter who does the recalibration, might be OPTRON, it might be us, that data is posted up to rec, and the next time you use your sensor, you get the right calibration. You don't have to worry about that aspect of managing the system. There's also the ability in the website to store data, to transfer information to our support team. And one other thing that we've worked a lot on is automatic monitoring of your sensor. So we record a lot of information like temperature and voltages and things like that while the sensor is flying. That information is sent up to our record website, where we have some analysis software that reviews it. And if there's any problem detected, it sends a message along with the log file to our support group. So we can do proactive support. We can contact you and say, hey, you know, it looks like you've got a problem with a camera, so forth and so on. We include the complete post-processing software that runs on the desktop. We think that's a much better approach than a web-based approach, because the LiDAR data is so voluminous.
40, the eye clinic. Yeah, I see.
This desktop software we call TrueView EVO. And it's based on some other software we have called LP360 that we've had for a long time, that's used in processing aerial LiDAR. And so because of that, this software has a lot of features beyond just post-processing TrueView sensor data. It's got capability. We'll go through that in just a second. The workflow is, it's wizard-based, quite simple. You start out with a wizard-based dialog that says, import your data that you just brought over from the sensor on a USB drive. So you can just register a project and start moving through it in this wizard workflow environment. If you don't want to process immediately, you just want to archive, that feature is offered as well. So it takes the data from the USB memory stick, puts it in an archive, and that allows you to process it later. And it also makes it easy to transfer it to other persons in your company. So you can push data off to the archive, somebody else can pick it up for processing. As soon as you do a data import, you get a graphic of what you have flown. This is really useful. So before you even do any data post-processing, you have a map of, you know, where have I flown? Did I cover the correct area that I was supposed to cover, and so forth. The imagery is an integral part of the workflow, so you can click on a point within the flight plan, look at images. They come into play in another mode that I'll talk about in just a minute. Processing the position orientation data can be somewhat intimidating, because these position orientation systems are meant for many different kinds of vehicles and many different kinds of platforms. So you're often presented with a lot more options than you need to use to process TrueView data. So we've enveloped the post-processing software for the Atlantic system within the TrueView workflow itself. So there's just a couple of steps on a wizard that allow you to set parameters. Most of them are pulled from information that was provided when you imported the project. So that step is really easy. And one nice bonus that you get out of this is that if you own a TrueView system, you have the post-processing software on your desktop. The primary way to do referencing is with a local base station. But if you do want to use Trimble RTX, it's available on a metered basis directly from within the workflow. So that's a really handy additional feature of the software. You usually don't want the entire trajectory that you flew. You want to be able to easily chop it up into, I just want, you know, the flight lines over my area of interest. I don't want the takeoff bits and the turns and so forth, the ferry lines. And so we have tools that automatically will call out the pieces that you don't want. And it's based on some simple logic like turn radiuses and length of individual flight lines and so forth. So we make pretty quick work of defining what flight lines it is you'd actually like to process. Once you've defined the flight lines, then geocoding the LiDAR data occurs. Really no user interaction here. We offer a couple of options for things like, oh, I don't want things that are over 40 degrees off nadir, or I don't want ranges beyond a certain range, that sort of thing. But Other than that, it's just push button, it processes. And at that point, this is usually about, if I flew a 15-minute flight, this is about 7 minutes of processing to get to this LAS data, point cloud data, that is in the traditional format that you see for laser scanners. So here, for example, I've colored by elevation. But then in TrueView, we add one more step, which is to colorize the points. There's no input to it. You just press start this process. As a matter of fact, when you do geocoding the LiDAR data, you can say, just go ahead and colorize it. We do this quite differently from other vendors. We don't colorize from an ortho photo. We colorize directly from the raw images that were used in the data collect. This gives a couple of advantages. The biggest one is just processing time. So within about 2 or 3 minutes on a typical flight, after the geocoding, I have colorized LiDAR points. So end to end, if I fly, say, a 20-minute flight, it's going to take perhaps 12 minutes from the ingest of data from the USB stick until I have a colorized point cloud. And here you see a plan view of that. So this makes the system very fast, very efficient. I'm off doing whatever my job is, ground classification, volumetrics, etc. I'm not waiting around hours and hours for photogrammetry to process. So remember, if you get a LiDAR system that colorizes from an ortho, you've got to go do that whole photogrammetry workflow before you get the ortho. And so that can add a lot of time to the processing stream. Another valuable aspect of how we do the colorization is that we trace every individual point to the source image, and that means that we can properly colorize vertical objects. So on the left side of these images, I've got a scene of the end of a building that was colorized from an ortho, sort of the traditional method of colorizing LiDAR data. And you see this, every vertical column here of points has the same color. Since I'm coloring from an ortho, there's only one color point I can have per vertical stack. And so I miss a lot of detail on this, at the end of this building. Here you see I'm doing colorization using the TrueView point projection method. And I can see the service door, I can see the walk-through doors beside it, just a lot more detail, a lot more color information within this image. Which, does it matter? Yeah, I think it matters because it aids tremendously when you're trying to interpret complex scenes. So again, this is a summary of what we've just gone through with the wizards that take you through the complete workflow. Something built into the software that, and we'll look at a couple slides on this, is accuracy assessment, which is critically important for almost any job that you're going to do. In addition to the normal tools of getting to a colorized point cloud, there's a lot of other tools that are available. We have point cloud smoothing, which is a really nice tool if you need to do hard surface analysis. We have automatic ground classification, a lot of tools for stockpile and volumetrics. So we can do direct volumetrics as well as differential volumetrics for borrow pits, cut and fill, those kinds of operations. Rail extraction, wire extraction. So quite a few capabilities in the software. That mostly comes from its LP360 heritage, because our software is used as a toolkit in LiDAR processing and everybody wants something different. So it winds up with a lot of tools. We also have a viewer capability that will let you view the point cloud just as you would in our TrueView EVO software. So profile view, 3D view, plan view. But you can also click on any 3D point and it will display all of the images that see that point. You can do some measurements from the images and so forth. So this is a great inspection tool. We've got a AECOM, as a matter of fact, that right now is flying a bridge, a metal bridge, and they're using this combination of LiDAR and feature data for bridge inspection. And a nice thing about this viewer is that you in turn can give it away free to your customers. We've just completed in our most recent release a packaging tool that will let you take your TrueView EVO project and export what we call an EVO Explorer package. It's just a single zipped file. Your customer imports it into the viewer and they can be in an environment like you see on the screen. So you can add a lot of value to your deliverables. And again, we already talked about the fact that we're integrated with Trimble's PPRTX processing. But we've extended TrueView EVO can also do post-processing, so PPK post-processing for both the Phantom 4 RTK and the M300 RTK with the new P1 camera. Calibration files for both those sensors are also supported in Reckon. So when you go into our TrueView EVO to process these two DJI camera systems, your workflow experience is the same as what you would do for LiDAR. So it really makes it easy to process. You're in a familiar environment, the outputs are the same and so forth. Of course, here you'd have to drive the images into a photogrammetry tool if what you ultimately wanted was a point cloud. And we support context capture, Pix4D, and Metashape formats. In addition, we have Metashape directly integrated into EVO, so you can move easily through that environment. Let's quickly go through a couple more slides to just show you some data and what's the difference between the systems. So the first one is precision. On a hard surface road, how much variability do I see vertically in the points? This grid that you see on the screen is 10 centimeter by 10 centimeter. And so you can see just what you would expect. Very solid in the Regal, bit more noise in the 515, and a little bit more in the TrueView 410. The TrueView 410 is a step above sensors like the Velodyne VLP16, certainly lower noise environment than that sensor. And of course, we quantify it, and there's tools within EVO itself to do this quantization or quantification. So you can go in and measure precision with some tools in TrueView EVO and get these results for yourself. So here we look at the difference between the three sensors, ranging in precision from 1.6 centimeters at 1 sigma for the 640 down to 4.2 centimeters for the 410. These are still pretty, even when you're at, when you're below 5 centimeters in precision, that's still what we consider a pretty quiet sensor. Wire detection is always important. We never advertise the 410 as a wire detector. You can see I get a few hits, not that great. I have to bring it down to say these are flown at 75 meters. I'll have to bring it down to 50 meters to get good wires with the TrueView 410. At 75 meters, the 515 is really saturating, no problem whatsoever. And the Regal system, of course, same way. No problem at all extracting wires. And you can see it's a bit cleaner, higher precision than the other sensors. You're always interested in ground detection, of course, so we did a test on a patch of piney woods. We had to do this in the winter, so that's about the most vegetation we could get. And you can see that all three of these sensors provide plenty of ground point density. The TrueView 410 at the lowest density is still at 15 points per meter squared. And how many points do you need on the ground? If you were out pogoing this with RTK, you'd have much thinner ground cover. And then, of course, network accuracy. What kind of network accuracy is achievable? Here are some typical projects that we can look at, ranging from 1.6 centimeters for the TrueView 640 Regal system, down to 3.5 centimeters for the TrueView 410. Again, in all three cases, excellent. What's survey grade and what isn't, I leave that up to you to decide. That's always a big debate in the industry. All these were flown at 75 meters above ground level. No geometric post-processing at all. So we didn't do any cleanup or anything. This is just completely raw data. And you can see that because we did not remove bias or mean error from any of these data sets. Removing mean error is a common operation and reduces the overall RMSE. Won't go through this decision matrix, but it's in the slide set that you'll get that says, how would you choose which sensor you want to use. All right, and that wraps it up for me, and I'll turn it back over to Sean at this point.
Am I there? Can anyone hear me?
Yep, hear you fine.
All right, excellent. Super, thanks, Lewis. Fantastic presentation, and thank you very much for sharing your many years of experience, and it's clearly visible in the products and the way they're put together and the thought that's gone into everything. It's fantastic. Thank you very much. So if you have a quick look, guys, at the the business side of things, if I can get my slides to change. There we go. All right. So what's in the box? If you buy a 410 today, the small screenshot on the side will show you everything housed inside a Pelican case, pretty much the same size as what you get with a Trimble GPS system. You got the laser, you got batteries, chargers, rugged case, as I said, and everything, and of course everything you need to fit onto your drone. These systems are sold excluding the drone, so you'd buy your drone separately. In our environment, we're promoting obviously the 410, the 515 with the DJI M300 as its primary carrier. If you're looking at the Regal sensor, the 635 or the 640, today you'd need to go with the M600, but it's close to end of life, the M600. So we'd need to track down a suitable platform for the 6 series. As Lewis said early on, done a lot of integration with a lot of different models of drones across the world. So there are certainly a lot to choose from. One that may be of interest would be something like the FreeFly Alta X, something down those lines. But for now, and I think in our market, the 410, the 515 on a 300 is pretty well suited to carrying out the majority of work that guys would need in our environment. What's included in the software purchase? So if you're buying a solution outright, you're getting a copy of TrueView EVO. You get POSPAC UAV desktop, which is integrated into the EVO workflow, and POSPAC Cloud on Demand, and of course you have access to the Reckon software for administering your whole process. There is also a subscription option, which we'll chat about a bit later, and you pretty much have access to the same variety of software, except it's on-demand based, essentially. All right, other things you can buy from us as OPTRON. So of course, well, as Lewis hasn't said, they're also DJI Enterprise dealers, and they've, as he said, they've sold SenseFly in the past and so on. And you obviously buy the drone from us if you need, and if there's a platform that, you know, if the DJI doesn't suit your needs, we will certainly go and look for other options for you in line with what the guys from GeoCue have done in terms of integration. So you can pick up the DJI systems from us, absolutely no problem. Of course, all the Trimble gear that we've been selling for years is available to support the process base stations, rovers, and so on. Support and training online, on site. As we're getting into the process, we'll still do a lot of we'll still need a little bit of assistance from the guys from GeoCue, but we've got plenty of very smart guys at OPTRON who will jump on quickly and be able to support you hands-on. As the nature of training and so on today has changed with COVID and all, a lot of online, but it's certainly still a very good platform to learn, and I think it brings people closer together much quicker. You don't have to travel everywhere and it can still be effective. A little snapshot on the side gives you an indication of what the sensor would look like on an M300. As Lewis spoke earlier on, there are also obviously positioning options. Most of the systems in our region would recommend using a single base setup on your site. You obviously have access to Atlantic Smart Base, which is a virtual reference solution. I've used it myself in mobile mapping systems in this country, and it's very, very effective. And of course, Trimble RTX as well, certainly available. Kinematic Minutes. So essentially, on the subscription side of things, and if you're using Planix Smart Base and some of the other solutions, you can buy access to flight time, essentially. So Kinematic Minutes is really the time that you're actually flying in your environment and collecting data. So if you're flying from the start point to where your flight data collection starts, is not counted as a kinematic minute. So you're really just paying for the time that you're actually collecting information. There's a snapshot of a conservative mission to give you an idea over the test site where the GeoCue guys are in Alabama. And yeah, 21 hectares, flight time around, kinematic flight time around 25 minutes. And we can chat more about time of flights and so on at a later stage if we get to that point in conversation. All right, so let's talk price quickly, just to give you guys an indication of where we're at in terms of price and what sort of systems cost. They're always interested to understand these sort of things. So a 410 system, we're looking at around 950,000 Rand, 1.3 million for a 515, and then upwards close to 3 million for the 6 series, and well past 3.5 for 640 system. So you can see we're not talking cheap in terms of rands and cents, but certainly you're getting exceptional value for your money and well worth having a look at. If those are alarming, there's also the option for a subscription solution, which we'll chat about in a few seconds. Let's actually get to it right away. So Lewis and his team have put together what they call the Evergreen subscription or rental. It's available on the 410, the 515 solutions, all right, of which we have units available in our Centurion store today. So if you've got an M300, you're ready to roll, give us a call. Yeah, you're looking at around about 120,000 Rand a month to rent that, which gives you access to 500 kinematic minutes of flight time, which is a lot of flying unless you're doing massive areas. But in most cases, a lot of smaller types of projects accumulated together and trying to get into the LiDAR world, this is a really good option to consider. One thing that's important to note, though, you need to have your own drone, so preferably to buy a M300 of choice, and you need to be legal in the drone space. We're not just going to rent this out willy-nilly to any Tom, Dick, and Harry, right? So you need to be established in the drone flying world with your own drone, and then wanting to get into the LiDAR space, and then we can support you in that for sure. If you're not active with an ROC, or at least running legally under an ROC, it's a difficult situation to be in. So we need to support the legal drone users in the country. For now, we're going to keep it local inside South Africa as a starting point, but of course there's options over into Africa for sure in the future. The idea is with this type of solution is to get you guys into LiDAR. Over a short period, limited. I mean, it's still money that you need to spend, but it's not massive amount of capital outlay, and you can start to get into the process, understand how it works, and build your business accordingly. Also, with subscriptions, there's no worries maintenance. So, of course, if you crash the drone, you're not covered. So we want to make sure you're insuring the kit for a set amount, but everything else is covered, and you always got the latest version, which is the latest version of software and so on, which is really, really important. Little snapshots of sample data. We can certainly provide you some sample data if you need. So on request, give us a shout, and we can provide you with something. Or, as I said, we have systems available locally. Do a demo, help you out, show you how the system works, and so on. It's really exciting technology. It's well put together. It's fantastic, and I think it's really, really good value for money in that survey mapping grade space. Quick summary to round up, and then we'll have some questions. So this relates back to a slide that Lewis had in the beginning. So the goals of producing these types of systems, I think, from what I've seen and the experiences I've had with TrueView and GeoCue over the last couple of months, is they certainly have exceeded what their goals were. I believe it's the best value LiDAR imaging system in the market today. The most important thing out of that, as well as being good value, is that it provides a complete solution, which I think is very important. And you often find with vendors across various industries is they'll provide you with a fantastic piece of hardware and then it ends. But okay, what do I do with the software? What do I do with the data afterwards? With the sensor well integrated into a drone, plus the processing software in TrueView EVO, you get a fantastic all-to-end solution that allows you to clean, export, classify data for various different applications. The 3D colorizing element of the EVO is really of the EVO software is really impressive. And I learned today, actually, just asking some questions of Lewis, a bit more about how their colorizing system works, and because they're not using orthos to generate the color on the cloud, you don't have to have as much overlap in your flight. You can fly maybe slightly higher. You can fly perhaps a little bit further, greater areas, and still have a colorized point cloud at the end of the day, which I think is fantastic. Last point on there in the summary, I think, is also very important as well, and that is that the guys, GeoCue guys, Lewis and his team, have been in the business for many years and have a significant amount of experience. They started, as you said, as a software company, Intergraph, come from Intergraph, Z9 Imaging, and so on. They know what you need to do in the software world, and they do it very well. And then add on some fantastic hardware to support it. So it's really good to know that we've teamed up with a partner for the long road. All right. Well, thank you very much for your time and everyone. Let me just quickly escape out of here and put on the other slideshow just to wrap it up. And if there are any questions, commentary, anything else that anyone wants to chat about, either on the chat box or yeah, you can unmute yourself and ask a question. We'll give a couple of minutes, and we've still got 8 minutes to go, so we're early. Fantastic. So anyone need to or want to ask any questions? Are there any, Brian, are there any questions in the chat box that people want to ask about?
Sean, I haven't seen any, but if anybody would like to, they can also raise their hand, ask questions, and they can unmute themselves. And then perhaps, Sean, you'd also like to repost the link for that form if anybody's interested, getting somebody to get back to them if they've got any questions or if they've got further queries. Good
point. I just pasted it into the chat. So there's a little form there, Smartsheet form. If you want us to get back to you for more info or whatever, you're welcome just to fill out your details and we'll get in touch. In that form as well, you can obviously add a comment if you want the presentation, viewing of the recording and so on. We will make that available, of course. All right, so no questions. Everyone happy? Well, okay. Well, thank you very much, everyone, for attending. I think it was a good session. Thanks, Lewis, for giving up your time today to share your experiences and some really fantastic hardware and software. And we really hope that we can join you guys on some of your survey mapping missions in the future with GeoCue UAV LiDAR kit. So yeah, once again, thank you very much and enjoy the rest of your day.
Yeah, I join you in saying thank you to everybody. Have a good day.
Thanks,